Okay, so in this video, we're going to look at how to convert a function in polar coordinates into parametric form. Now, there's two reasons for doing this. So first of all, sometimes we may want to actually look at a graph of a polar coordinate function in parametric form. And the second reason is that we're going to use the parametric form in order to actually create our derivative dy dx as a derivative. We're going to need that parametric form in order to come up with the derivative for dy dx in polar form. So the thing to remember about parametric forms of equations is that we have this general relationship that x is equal to r cosine t, and y is equal to r sine t. Now, in this relationship, we're normally using this to swap out for a circle where the r value is a constant. So in polar form, a circle is just like r equals 3. And then when we put that in front of the coordinates, cosine and sine, what we get is 3 cosine t and 3 sine t, and then that becomes our equation of a circle. But we can actually use this relationship more generally. We're going to replace theta with t, and then replace r with r of t. And so x will become r of t cosine t, and then y will become r of t sine t, just in general. So if I want to create the set of parametric equations that represents this particular polar graph, then what I would end up with is x of t is equal to 2 cosine 2t cosine t, and then y of t is equal to 2 cosine 2t sine of t. Now let's actually test this out in a polar coordinate and a parametric function grapher. So 2 cosine 2t, let's go to our polar grapher. And this is our example that's on the screen. And so we're just going to show the first graph by checking it. So it looks like this. So our 2 cosine 2 theta is going to look like this. Now, what does this look like in parametric form? Well, let's switch over to our parametric grapher. And let's change our function here to represent our function we want to graph, which was 2 cosine 2t cosine t and 2 cosine 2t sine t. And looky there, we have exactly the same graph in polar form and in parametric form. So that's all you need to do. You just use this relationship that we're accustomed to only using with a circle, replacing r with a constant to get our circles. But in fact, you can replace them, those r's, with functions of t, with functions of theta, and then you also get your parametric form of your polar coordinates.